Bismillahirrahmanirrahim. Assalamu alaikum. Students, how are you all? I hope you all are fine. Students, in the previous lecture, we have discussed about the water pressure. We also have discussed that what exactly the water pressure is and on which factors water pressure depends upon. At the end of the lecture, we have discussed the key points that what are the two main things which actually increases the water pressure. So today we are going to proceed further, but before that, let's have a look on our content today. Today we are going to discuss first, it's an interesting information, and the information is on page number 103. Then after that, we are going to discuss, do you know, the another very interesting information, and at the end we are going to discuss our main topic, that is activity number 7.5, liquid pressure in a closed container. So let's get started. Interesting information. Dear students, kindly open up your books, page number 103, and there are a few lines written here, and I hope you all are well aware of these lines as well, not in the form of the digits or something like that, but the people who are swimmer and the girls and boys who are swimmer, they must know about this thing. In the previous article, we have discussed that water pressure increases as we are moving towards the depth. So basically at page number 103, there are some facts given, and the point number 1 is written here, and it is water pressure increases 10,000 pascals for every 1 meter down in lake or ocean. That is why diver feels an increase of pressure on eardrum. You all know that whenever you are moving towards the depth of ocean or lake or river or whatever, then water pressure increases. Then what is the intensity of the water pressure to be increases? It mostly is 10,000 pascals. If you are going just 1 meter down, then water pressure increases 10,000 pascals. How you actually feel that pressure on yourself? That is that you are having an increase of pressure on your eardrum. So it's more easy to swim at the surface than at the bottom. Okay, the second point is the deeper you go underwater, the greater is the water pressure pushing down on you, because we know that water pressure increases if you are moving downward. So because of that, you are having a water pressure on yourself. You are feeling it like that, that water is just pushing you in the downward direction. Okay, now next we are having, do you know? This is also a sort of a question, or you can say that a discussion. These sort of questions mostly comes in your section B, in physics section B. These are reasoning questions, and you have to write down the answer. The points slide, which is actually displaying here, it is on page number 102 of your science book, chapter number 7. You can have your books along with you so that you might relate your topic with the book as well. So the question written in the book is, why the supporting wall of the dam is built very broad at the bottom. Now there comes a answer in your mind, and you must be able to answer me about the question which is written here. Yes, please try and give me the answer. Is there anyone who can give the answer of that question? Yes. Just relate this question with the water pressure. As we know that, don't read the slide, as I'm not going to read it. Just relate the points. Why the supporting wall of dam is built broader at the bottom? So it is broad at the bottom, it is not broader at the top. Then there must be something at the bottom. We know that water pressure at the bottom is more as compared to the top. So because of that, it is the reason that there are the chances that the wall may got damaged if the walls are not very broad at the bottom. So in order to bear up the pressure, water pressure at the bottom, the walls are made broader. Now the answer is abrupt, as I've just giving you the points. So the proper answer is this one. The reason is that the pressure exerted by a liquid increases with its depth. Okay, thus as the depth increases, more and more pressure is exerted by water on walls of the dam. A thicker wall is required to withstand greater pressure. Therefore, the thickness of the dam increases towards the bottom, as we have discussed earlier. What we have discussed, that as the water pressure at the bottom is more, and if the walls are made not broad, they are not very thick, then it's It's very difficult for the wall to bear the pressure of the water, and obviously it got damaged. So in order to avoid this, mostly the wall of the dam at the bottom is made broader. There is a very rough diagram given in your book at page number 102. You can have a look on that diagram as well. The wall at the bottom is broad, but it is not at all broad at the top. And the reason is very simple, that water pressure at the depth is more. It's not more at the top. So in order to have a look on it, the walls of the dams are made broader at the bottom. Okay. Students, kindly read these points, read these questions, and try to write the answer in your own words, and so that you might be able to answer the questions which are reasoning questions and which are short questions as well. Okay, now we are going to move towards our main topic, and that is our activity number 7.5, liquid pressure in a closed container. Dear students, before going to discuss the topic into the detail, let me tell you a thing. The topic is also related with the liquid pressure, as we have discussed earlier, liquid pressure, but the point which is very important is it's a closed container. So you must say that it is also about water pressure, but there is a restriction, there is a condition, that now we are going to discuss the liquid pressure in a closed container. Okay, so let's have a look from the initial points, and then we will proceed further and I will explain the topic in detail. The point is, a liquid enclosed in a container exerts pressure equally in all directions. Now, dear students, kindly recall your previous article, that is activity number 7.1, in which we are having a bottle and we make hole at 3 different heights. And what we have observed, that the water coming from the 3 holes, it falls at different distances. Means that the water which is ejecting from the holes will not have the same pressure. Then what we are saying here, liquid enclosed in a container exerts pressure equally in all directions. Why we are saying this? We are saying this just because of the thing, as I already have discussed with you, that there is a condition, and the condition is enclosed. The container is closed. There is nothing like a previous experiment in which we are having a simple PET bottle, we are having a holes in it, and water is just ejecting from it. We are having a container which is closed. How? We are having a piston here, or you can say that sometimes we are having, you may actually relate it with the injection. You all have seen the injection, no? There is a plunger at the back. We are going to push that plunger inside it so that the medicine or the liquid which is used to inject into the patient move equally and it just comes out from the syringe. So kindly relate this piston with that plunger, wo jo injection mein hota hai. Okay, don't get confused what we are talking about. So basically this is a special condition. The condition is this, that if a container is closed, if we are applying an external force, we are pushing the plunger into the bottle, into the container, then there is a condition that water will comes out from all the holes, obviously with a same pressure. It will not fall at different distances. I'm going to discuss this in detail. At the end, I will explain this point again because it needs a little bit more explanation. Okay. So this is the activity. The activity is on page number 103 and it is activity number 7.5. The point is, liquid enclosed in a container exerts pressure equally in all directions. Or you can also say it like liquid pressure in a closed container. Both the statements are equal. Now, dear students, we are going to discuss first our material required, as we have done already in the previous activities. So first we need material required. We need a plastic bottle fitted with a piston at its mouth. This is the piston. It is known as plunger, it is known as a piston. As I have already told you that you can relate with the injection in which there is a plunger at the back and we need to push that plunger if we want the medicine or the liquid to just come out from the syringe. Okay, then we need a water tub, and these are the main things which we need. Okay, for the procedure, what we need? First, we need this plastic bottle, and the condition of the plastic bottle is that there must be a piston which is fitted at the mouth of this plastic bottle. Now, the second step is we need to make students, I hope the diagram is clear to you. If it's not, kindly have a look on the diagram which is given on page number 103. Okay, we need to make some random holes on these bottles. For example, this randomly. We need not to make the holes like in the previous activity we have done at this height or at this height. No need to make it. Just make the random holes and make few holes in the bottle. Okay, after that, what you really need to do is you have to dip this round part of the bottle, this one, into the water tub. Okay, and after putting the plastic bottle into the tub, you need to push back this plunger or piston. Why we are doing so? Actually, we want to fill the water into the plastic bottle. It is simple. Simply, you can relate it to the injection. Like suppose you are going to put your injection into the medicine, with the liquid medicine, and just put it over there for a few minutes. The medicine will not get into the injection unless you are just pulling the plunger. Okay, so it is actually the same one. Now just pull back the plunger, this one, and what is actually going on? The water will just get filled into the plastic bottle. Dip the round part of the bottle in the water contained in a tub or vessel and pull the piston or plunger out to fill the bottle with water. Okay, now after that, what you really need to do is now take out that plastic bottle out of the tub. Okay, because we have filled our bottle, and now this next step is you have to push the piston inside the bottle. Now push the piston or plunger and observe what is going on there. Observe the water flowing out of the holes in the bottle. Now, dear students, before going to discuss the conclusion of the activity, let me give you a very simple point just to get the answer. Just have a look. Suppose we don't have a plunger here. If we don't have a plunger here, then how the water stains come out? It's very simple. Obviously, from this, it falls at their distance. This falls a bit here, and this one at the far distance, as we have discussed already in our activity 7.4. But now in this activity, we are having an external force. It's very simple to understand. If we are applying a force here, we are pushing the water layers equally. And the result is water will come out with same pressure from all the holes. As water will come out with same pressure from all the holes, then the speed of the water from all the holes is equal. And it covers the same distance. Basically, it falls at the same distance. Like if this stream falls at this point, this one, and rest of the others also fall at the same point. Like these three falls at here. So dear students, if the external force is applied, then water pressure from all the holes will remain same and it will fall at the same distance because we are applying an external force on the bottom. So we must have this in a proper form as well. What is actually the conclusion of this one? So this is the conclusion. If the liquid is trapped, filled, contained in a container and pressure is applied, pressure means that you are applying an external force over it in the form of a piston or in the form of a plunger. Then pressure will be transmitted equally in all directions. Okay, now there is a very important point. If the force is not there, then there comes a point. Then water will not come out with same pressure. Okay, now dear students, after this point, that if the external force is applied on a liquid or a fluid, then water or the liquid or fluid will come out with same pressure, will leads us towards a law. And the law is actually known as Pascal's law. Now, what the Pascal's law is? Before going to discuss the Pascal's law, let me share a very important thing with you. That is, according to Pascal's principle, all the water that moves out from the holes receive the same pressure. In the next slide, I'm going to explain Pascal's law as well, but kindly try to relate this thing that this is actually the main principle of Pascal's law, that if an external force is applied, then water experience the pressure which is equal from all the sides. Now, Pascal's law. The law states that the pressure is exerted on a fluid in a vessel is transmitted equally in all directions. Now, the definition or the statement of the Pascal's law is also given on page number 103, and I'm going to read it first and then I'll go to the slide. Kindly listen it carefully. The law actually is discovered by the person whose name was Pascal. He was a French scientist, and on the name of and actually on the achievement of the person, the law was named as Pascal's law. Okay. Second thing, the law is applied to the fluid which are filled in a vessels. Okay, the closed vessels. Pascal's law is applicable to the fluids which are filled in the closed vessels. Okay, now the main point and the next point is, which is actually the statement of the Pascal's law. What actually Pascal's law states that, it simply states that whenever a liquid is enclosed in a container, then a force is applied or pressure is exerted on the fluid, then that is transmitted equally in all directions. Okay, the diagram related to this is also given, and I'm going to discuss this as well. But first point is that you must know what actually the statement of Pascal's law is. So if a force is applied, external force is applied, then in the presence of the external force, the pressure is transmitted equally in all the directions. Okay. Now there comes a very important point, and first we have discussed that whenever an external force is applied, listen carefully, whenever an external force is applied, then what happens? Then pressure is transmitted equally in all the directions. This is basically the main principle of Pascal's law. And we have discussed this thing, that Pascal's law is applied only on the fluids which are contained in the closed vessels. Now, after that, we really need to discuss what actually the Pascal's law cater about. Dear students, after the discussion of Pascal's law, we come across with the branch of science which is actually known as hydraulics. Now, the principle which we have discussed, that is actually the Pascal's law, is covered in hydraulics, the branch of science which is known as hydraulics. Kindly have a look on this line. Hydraulic system works on the principle of Pascal's law. So whole the hydraulic system works on this principle, and the principle is very simple. Have a look here. If there is a liquid, fluid which is enclosed in a container, doesn't matter the shape of the container, okay, and external force is applied here, then the whole pressure is transmitted equally in the liquid, and it is actually transmitted throughout the liquid in an equal way. Now we are going to define what actually the hydraulics is. Listen it is written on the first point as well, but I am going to read it from the book. Okay, page number 103. The branch of science which deals with the transmission of fluid pressure through pipe as a source of mechanical force is called hydraulics. Again, from the slide, the branch of science deals with fluid pressure in pipe. Now, what does it simply mean? It simply means that hydraulics covers here in the situation whenever the liquids or fluids are enclosed in the form of this way, that they are closed in pipes, and whenever an external force is applied, it is transmitted equally from all the points. Basically, the liquid experiences the same force and it is transmitted equally from one side to next side. And what is the purpose of this? This basically used to do some mechanical work. Students, what sort of mechanical works are these? We are going to discuss in the next lecture, because we are having a huge topic which actually covers this point. So I'm not going to discuss this point here. Okay. So Basically, Pascal's law is the main principle, which is actually the base of the hydraulic system. And hydraulic system is used to do a lot of mechanical works in our daily life. What actually the hydraulics is? It is the transmission of fluid pressure, okay, transmission of fluid pressure that is through the pipes, which is a source of do mechanical tasks. Okay, now next point. At the end, dear students, I'm just going to compile all the points which we have discussed today. First, we have discussed about the water pressure, that water pressure increases 10,000 pascals if we are going just 1 meter down, and because of that, the walls, the dams are made broader at the bottom so that they bear out the water pressure. After that, we have discussed about the liquid pressure in closed containers. We have discussed that whenever the external force is applied, then water pressure is different in a way that actually liquid or fluid experience the same pressure, and it shows the equal transmission of pressure from all the sides. This law and this principle basically leads to the Pascal's law, and Pascal's law is the main and basics of the hydraulics, which actually covers all the Pascal's principles and used to do a lot of tasks in our daily life. Last point, dear students, the written work regarding with this topic is also given in the separate file, as already in the previous lectures we have done. The point which is very important is kindly do your physics task homework on your notebooks, and after that you have to upload the images of your notebooks. The method and procedures how to do it are already explained in your WhatsApp group. Kindly follow the procedures and try to complete the task within the due dates. Okay, that is all for today's lecture. I hope today's lecture is useful and informative for you. Read out your book to get the more answers. Thank you so much. Have a nice day, and Allah Hafiz.